Hello, this is another riveting video for pre-calc. This is section 4.1. And we're going to talk about how to convert angles and their measures. So we start off with degrees and we break it down. The degree, minute, second system is used mainly for finding geographical locations based on latitude and longitude. So a lot of folks who fly airplanes or drive boats are going to use degrees, minutes, seconds. So we need to have a bit of a general understanding that this is out there and it's usable. So our symbols, obviously we have the degree symbol, an apostrophe is for minutes, and a double apostrophe tells us about seconds. So first order of business is to convert degrees to degrees, minutes, and seconds. You'll notice that I have a decimal here, 37.425. Well, the nice thing about degrees, minutes, seconds is the degree part is very simple. Alright, 37 is the degree part. Remember, I need my degrees, my minutes, and my seconds. So we said that our degrees was 37. So we're going to use the decimal part to find out our minutes and seconds. So we have 425, and we're going to multiply this by 60 because there are 60 minutes in 1 hour, or in 1 degree there are 60 minutes, and we end up with 25.5. So once again, we're going to break this up. 25 is my minutes part, and the 0.5 is my seconds part, and we need to convert that to whole seconds. So we're going to take our 0.5 and again multiply by 60 because I know there are 60 seconds in 1 minute. When I do that, I get 30. So I have 30 seconds. So my answer is 37 degrees, 25 minutes, 30 seconds. So that was how we converted. Remember, we only look at the decimal part when we're looking for the minutes and the seconds. The whole number is what is the number of degrees or the number of minutes. Alright, you try this one. Go ahead and pause the video and come back and check your answer. Go ahead and check your answer. You should have gotten 99 degrees, 22 minutes, and 12 seconds. As we move on here, now we gotta go back the other way. This gets a little trickier because we now have to consider everything in terms of degrees. So when we work backwards, we take each part, and we know we have 42 degrees plus 24 over 60, because we said there were 60 minutes in 1 degree. So now we're dividing instead of multiplying because we're working the other way. But this is where the seconds comes in, because it's not divided by 60 again. It's 36 divided by 3600, and the 3600 comes because there are 60 seconds in 1 minute and then 60 minutes in 1 degree, so there are actually 3600 seconds in 1 degree. When I do this, I have fraction, so those are going to help convert into my decimals. Go ahead and type that guy in your calculator, and you should get 42.41. If you're not sure if you did it right and you understand how to convert from degrees to degrees, minutes, seconds, you can go backwards to check your answer. But remember, on this it's degrees, so we need to make sure we put our symbol. Symbols are very important. You go ahead and try this one and then come back and check your answer. And you should get 48.51 degrees. Make sure you are entering things using your parentheses when you enter them in your calculator. It is a good idea to put parentheses around both of your big fractions here. Our next order of business is how do I convert from degrees to radians? As we move forward after Christmas break, we're going to spend a lot of time talking about the unit circle, and when we talk about the unit circle, we spend a lot of time in radians. So it's a good idea to get a good understanding of radians. Now, when we convert, it's a simple ratio. The number of degrees over 180 equals the number of radians over pi. Okay, and now that I have a proportion, as Mr. Luke likes to, we can cross multiply and divide. So let's do a couple examples. If I have 150 degrees, I'm going to do 150 divided by 180 equals my radians, which I don't know, so that's my R, over pi. And when it comes to radians, when you're talking about radian measures, leave your answer with pi. Do not use 3.14 at all for this unless you are explicitly asked to do so. 3.14 is no longer acceptable. We have to learn how to understand what pi actually is. So I do my normal solving for proportions, and I'm going to cross multiply. Boom, I get 150 pi equals 180R, and divide by 180. And I get R equals 150 pi over 180. Go ahead and simplify your fraction. Leave the pi out when you're entering this in your calculator. Enter in 150 divided by 180. And your calculator will simplify that down for you to 5 pi over 6. Make sure you use pi if you can. Now in your example, notice you have a decimal. So you may not come out with an actual fraction or a pi value. Let's go ahead and pause the video. You try it and let's see what you get. Go ahead and check your answer. You should have ended up with 0.0657 pi. So does it matter that I didn't have a fraction this time? Absolutely not. It just matters that you do not start multiplying by that pi. Leave pi out front. Alright, let's go the other way. Let's convert from radians to degrees. This requires a little bit more of a thought process here. So degrees is what I don't know. Whoops. So d over 180 equals 3 pi over 5 divided by pi. Now when I cross multiply, I'm going to end up with d pi equals 108 pi. If I divide both sides by pi, the pi's cancel out, so d equals 108 degrees. And make sure you label your degree measure with degrees so you know what we're talking about. If a number does not have a degree measure, it is assumed to be a radian. And that is very important, as we found out when we were checking our calculators in section 4.2. So make sure, if you're converting to degrees, that you do use that degree symbol. Now go ahead and attempt the student example, pause the video, and come back and check your answer. And for an answer, you should have gotten d equals 117 degrees. Remember, these are straight up proportions. If I'm given an answer in radians, I plug it into the radian spot above the pi. If I'm given an answer in degrees, I plug it in above the 180 in the degree spot. Now, our next topic is talking about arc length. Now, what is the distance of the intercepted arc created by the given angle? It is the arc length. So, we have some symbols. S is our intercepted arc. R is the radius of our circle. Theta is our central angle. And our formula is S equals R theta. So, we're simply going to use this formula to solve some problems. Alright, and theta, very important to note, must be in radians. So why did we just talk about how to convert from degrees to radians? So that we can use it to find the arc length. So use the appropriate arc length formula to find the missing information. Remember, our formula is S equals R theta. So whatever's in this column equals these two multiplied together. But they have to be in radians. So, very nicely, Mr. Luke gave us both of our thetas in radians. Let's go ahead and solve for the first one. We're solving for S. So, in order to get S, I take a look, and I see that 1 times 70 is 70, so S equals 70 in this case. I, yes, literally just multiplied those two together. Now I have 2.5 equals R, which I don't know, times pi over 3. How do I undo multiplication? I divide. So divide both sides by pi over 3. And I get R equals 2.387. Alright, so that is, and it's centimeters, because it says in centimeters right here. That is our radius. Now, in this case, make sure when you're dividing by pi over 3 that you use the pi symbol on your calculator. Like I said before, we are no longer using 3.14. You need to be as exact as possible. And in our final example, I have 4 equals 7 theta. Divide both sides by 7. So theta must equal 0.571 radians. And remember here we got 2.387 centimeters. Okay, so everything is going back to S equals R theta, which we will use again after Christmas break. Now it's your turn. Go ahead and pause the video and come back and check your answers. Go ahead and check your answers to the chart. Our last concept of the day is once again a story problem. You're going to run into a lot of these in this chapter, so be prepared. From a point 100 foot from its base, the angle of elevation of the top of the Arch of Septimus Severus in Rome, Italy is 34 degrees, 13 minutes, and 12 seconds. How tall is the monument? So first, if I draw my picture, alright, I know that from a point 100 feet from its base, so this side is 100, my angle of elevation, so this angle is 34 degrees, 13 seconds, and 12 minutes. But I have to change that in order to use, I have to change it to degrees in order to use it to find my solution. So to change this to degrees, remember I have 34 plus 13 over 60 plus 12 over 3600 equals 34.22 degrees. So this goes up here for my angle. Now this is my opposite side. This is my adjacent side. So because I have opposite and adjacent, I'm going to say the tangent of 34.22 degrees equals x opposite over 100. Multiply both sides by 100 and I get x equals 68.01 feet is how tall we get for the Arch of Septimus Severus. Alright. Now, your homework today comes from 2 separate pages. One is actually section 4.1. It's page 356, 1 to 31 odds. The second part is the story problems, and those come from page 432. And we have number 7, 9, 12, and 20 for you to attempt. Remember, all solutions are posted to eChalk, so please check your answers when you're done. Have a nice day.